Hello everyone, my name is Varun. In this video, we are going to discuss about F5 high availability. So what is high availability? For any application or website that has been deployed, it is important to have load balancing and high availability implemented to sustain high traffic and failover in case your primary infrastructure goes down. So HA makes sure that server pool is ready for user request in situation where the primary load balancer is down, and you can redirect the traffic to your secondary node with very minimum downtime, which is not noticeable. So with high HA you have two nodes, one of which is processing the traffic and another one is standby. So if any failure occur with the node 1, the node 2 will be capable of taking all the load with minimum downtime. So how HA is deployed in F5? You have two systems. One act as an active system, other as a standby system. So the goal of such redundant peering is to provide user with seamless, uninterrupted services in the event of failure on one device. So what happens if the active system is taken offline or fails to connect? The standby system immediately takes over to avoid processing traffic. Typically, the newly active system remains active until an event requires the first big IP system to become active again, or until you manually force that system into standby. So if you have two F5 nodes in HA, and if the primary goes down, the secondary one will become the primary, and it will remain primary even if the secondary comes the old primary comes up. And if you want the old primary to become active, you can do it manually. So there are two types of deployment in HA. One is active, another one is active standby. With active deployment, both the nodes act as active. So you basically create two traffic groups. For one traffic group, one node is active, and for the other node is active, and both act as a failover for each other. With active standby, there is a single traffic group is active on one of the device in the device group and is in standby state on a peer device. If failover occurs, the standby traffic group on the peer device becomes active and begins processing the application traffic. So with active standby, if you have two F5 nodes in HA, there will be only one traffic group, and one node would be the primary for it, another one will act as a standby, and that would be used if failover occurs. So how F5 HA works is, there is a concept of floating IP. The floating IP floats between the active and the standby device, and both the devices sync the complete configuration with each other. So if the active device fails over, the floating IP will become active on the standby device, and prior to failover, both the devices sync their database. So today this is our lab topology where the client, there would be two load balancer, LB01 and LB02, with the internal IP 192.168.31.3 and 192.168.31.4, and there will be a floating IP that is 192.168.31.7. So let's configure the lab first. So we have two nodes. One node management IP is 192.168.1.1.10, and another node is so these are our two F5 node. As of now, they are configured as standalone. So we will configure them in HA. So these are the two nodes. See, as of now, these are showing as standalone. Once it is configured in HA, it will either show that active or standby. So if we talk about the configuration, these have a basic configuration for now. So this has the basic configuration for now. Basically, if you go to the networks, they only have internal and external IP configured. Okay, so in order to configure HA, we need a HA self IP, which will be used to sync the data. If you want, you can use the management IP as well, but we will be using the HA IP to sync the data. So we have to first create a self IP for HA. So prior to that, we have to create a VLAN for it. So if we go to the VLANs, we already have a HA VLAN configured. So we'll create an HA IP that will be used to sync the configuration between two of the nodes. So go to create. I'll name it as LB underscore HA, right? And IP address we will be using is 192.168.21.3. It will be using the HA VLAN. Okay, now we'll finish it. So now we have three self IP, right? One is for the external interface, one is for the internal interface, and the third one is to sync the data between two of the devices. Now in order for HA to work, as we already discussed, there is a concept of floating self IP. Okay, so this, if we talk about this IP 192.168.31.2, it is non-floating self IP. It means that it remains on individual F5. It will not move from one F5 to another. So for HA, we have to configure floating self IP in the same VLAN. So we will configure the floating self IP. We'll name it as internal underscore floating. Okay, and the IP address will be 192.168.31.7. okay, net mask is 255.255.255.0, and it will be using the VLAN LB south, as it is for internal traffic. Okay, now we have an option to select the traffic group. By default, there are two traffic group. One is traffic group local, another one is traffic group 1. So traffic group local remains local to the F5, and group 1 is a floating traffic group. By default, you have traffic group 1 as a floating traffic group. If you want, you can create other traffic group as well, floating traffic group as well. So as this IP will be floating between two F5s, so we'll make it a part of traffic group 1, that is a floating traffic group. Finish. Similar configuration we have to do on another node. It also have only two IP configured, right? So we have to create an HA self IP first. So this would be our HA IP for this node. It will be using the HA VLAN. Hit finish. Now we have to configure the same floating IP that we have configured in this node, that was 31.7. So I'll create a floating IP here as well. hit finish. So for now, what we have done, we have configured the HS self IP that would be used for as a failover interface and in order to sync the configuration. So it is optional, you can use any of the self IP, but we have configured a separate self IP for config synchronization and the failover, and we also configured a floating IP that would be floating from one F5 to another. Now we will go to the node which we want to make active and go to the device management. First, what we have to do is we have to add a device trust. So we'll add a member. Here we will put the IP of this load balancer, management IP of this load balancer. So that is and the admin username and password. Now we'll retrieve the device information. So now it is able to successfully retrieve the device information. This is the certificate of that node 11120. Now we'll click on device certificate matches. So while adding, we got an error that it does not have the config sync address set. So before adding the devices, we have to first configure the config sync address. In order to do it, we have to go to the particular F5 node and go to devices. Go to the config sync. So we already have our address configured for sync, that is the HIP. We will be using this for the sync. Update this. Also configure the failover network that would be used to fail over the traffic from one node to another. So click add. Now again we will be using this node only, and this and the failover occurs at port 1026. So this is by default. Click finish. Now for mirroring, this will mirror the connection from one F5 to another in case of failure. So again we will be using the HIP only for this. Hit update. Similarly, we have to do this on the another node as well. So go to the device management, devices. So this is the lab02lab.com F5. So we go there. And again here we have to configure config sync, the address that would be used to sync the configuration between two nodes. So again this will be HIP self IP. Now we have to configure the failover network as well on this node. So go to add. So we are going to use the HA self IP and the port is 1026 by default. Click finish. Now mirroring. So again we will be using the HIP for mirroring as well. Okay, so it's done. So as of now, what we have done, we have configured a HS self IP that is used for the config sync, failover network and mirroring between two nodes. We have configured a floating self IP that will be floating between two nodes. Now we are going to add device with each other. So what we have to go is we have to go to device trust and add a device trust member. Now the management IP of the other node. not retrieve device information. So this is the certificate of the other node. So click device certificate matches. Now we'll just click on add device. Once the device test is added, we have to create a device group. So go to the device group and click on add. So we'll name this device group as lab. So there are two options. One is sync only, another one is sync failover. So with sync only, what it will does is the configuration will be synced between two devices. The primary configuration will be synced with the secondary or the standby F5, but there will be no failover. But in our case, we need both sync and the failover. So we'll select sync and failover. Now we have to add the devices that we wanted to be in this group. So these are the two devices. This is the local device on which we are configuring, and this is the another node for which we have added the trust. Now sync type, either you can have automatic with incremental sync, manual with incremental sync, or manual with full sync. So with automatic sync, the configuration will be synced automatically. You need not to manually sync it. But with manual sync, you have to go to overview under device management and then do a manual sync. So we will be doing manual and with incremental sync. Okay, so now the devices are added in this group. Okay, now this device has become active and another device, okay, let's let the initial sync complete first. It is awaiting initial sync. So for initial sync, we have to go to the overview. Okay, see, once we go to the overview for initial sync, for the manual sync, we have to go to overview under device management. But as of now, this device is showing us offline. So we will not be able to sync it. That is why if we go to another node, it is not showing it standalone, because as of now, they are not able to sync with each other. So as we have configured it, the group as sync failover. So both the devices should be able to communicate with each other over the failover port. So if we go to the devices, and if we go to any of the device, for failover network, we have this IP configured, right? And for failover, by default the port used is 1026. So we are using HAIP for failover between two nodes, and both the HA nodes should be able to communicate with each other over port 1026 using the self IP. So in order to do this, we have to go to the self IP and allow the port 1026 first. So we'll go to the self IP. Go to the HA, which is used for failover, and see under port lockdown we haven't allowed any port, so we have to allow the HA port first in order for two devices to be in sync. So what we have to do is we go allow custom, right? This is a UDP port by default, and we'll add 1026 and update. Similarly, we have to go to the other node, go to the self IPs, go to LBHA. Again, no port is allowed, so we do it custom. We add port 1026. Now once it is added, now if we go to the overview, see now we are seeing that node as online. Okay, so what we can do is we can sync. So what we are going to do is we will be syncing the configuration of lab01 to lab02. So we have selected push the selected device configuration to the group, means whatever configuration is there on the lab01 will be there on lab02 as well. Once we click sync, so now the syncing is in process. So once the initial sync is done, now the F5 is in sync. So one of the node become the standby and another one become the active. So now both the nodes are in sync. So whatever config we will do on the one node, that will be automatically that needs to be manually synced, as we have selected the manual sync option. So whatever configuration we do, if we do a manual sync, then that configuration will be available on the another node as well. So let's configure a load balancer now. So we'll add a node first. So there are two nodes already added, right? So once these two F5 are in sync, both the F5 would be having these two nodes configured. So, and if I delete one node on this F5, let me delete this node. So if I remove this node from here, then it shows that there are changes which has been done on this node and it is not yet synced. So in order to sync that changes, I'll click here. Now it shows me that this F5 is configured at 640 and the another node was configured at 627. So this is the latest configuration. Now what I'll do, I'll push this device configuration to this group and sync the configuration. Now the configuration is synced. Now if we check on this F5, it will be only having one node. So this F5 is automatically synced with the configuration and now it has only one node. So we'll configure a virtual server now on the active node. Name would be web. Okay, standard virtual server. The address would be 92.168.31.10. Okay, port would be 80. And this will be using automap. Okay. Finish. now we have the virtual server configured in this node. So if we go to this virtual server, we go to the resources to add a pool. This will be the default pool. Now after the virtual server configuration, this shows the changes are pending, and if we go to the other node, it doesn't have the virtual server configuration as of now, because we haven't synced the F5 manually. So what we have to do, we have to again click on changes pending. Now this is the F5 which is latest configured at 646. So what we will do, we'll select this F5 and then we will push the configuration to the group. Hit on sync. Now the F5 are in sync. So if we go to the standby node again, and if we just refresh it, now it has the web server configuration. So we have verified that the sync is working fine. Now see how, now we will test the failover. In order to test the failover, we'll put a ping on the virtual server IP. As of now, this virtual server is active on this node, and what we will be doing, we will make this node offline, and then we will see how failover works and how other node become active. Okay, so what we have to do, we simply go to this node and shut it down. So now this node is shutting down. Let's monitor the ping response. As of now, this node is up. It is not yet down. See, once the node goes down, there were two timeout, and now the other node become active. So this is how failover works. There was a slight disruption in the traffic. Now this node will become as active. See, now this node is active and the other node is down. So our failover is working. Still we are able to access the virtual server through this node. This is how failover works in F5. Hope this video is helpful for you. If you like this video, please do subscribe to my channel and like this video. Thank you.